Let us see the ideal and practical characteristics of a diode. Consider this example when this LED will glow. So I have a 2.5 volt battery source. The switch is in open position, so the LED will not glow. So voltage across the LED will become 0. The entire applied voltage will be applied across the switch. Now when this LED will glow, definitely you have to close your switch. If I close the switch, what will happen? This 2.5 volt, the circuit will be a closed circuit. So the entire 2.5 volt will be applied across the LED. Then the voltage across the switch is 0 volt. So in this case, your LED will glow brightly. In the previous case, during off state, our applied voltage will be applied across the switch. During on state, the voltage across the switch is 0. The entire voltage is transferred to load. So this is the basic idea behind the ideal switch. If it is an ideal switch, then it has some the following characteristics. When it is in open condition, the voltage across the switch must be infinity. It means your switch has to withstand infinite voltage during open condition. The current flowing through the switch is 0. If the current is 0 means automatically the resistance will be infinity. So R equal to infinity. When the switch is in closed condition, the voltage drop across the switch must be 0 and the current flowing through the circuit is infinity. It means your switch must able to withstand infinite amount of current. So if it is voltage equal to 0 means short circuit. In short circuit your resistance equal to 0 ohm. So these are the ideal characteristics of a switch. Is practical diode an ideal switch? No. Practical diode, it is not an ideal switch because it has small on-state resistance due to R-on. There will be a voltage drop across it when it is forward biased. For an ideal diode, your R-on will be equal to 0. That is on-state resistance equal to 0. For example, if it is an ideal diode, we are applying 2.5 volt. This is anode and cathode terminal. Anode is connected to positive, cathode is connected to negative. So the diode is in forward biased. So forward bias, your diode will conduct the electric current. So there will be a flow of current I. That is IAK. IAK means anode to cathode current. So the entire voltage is applied across the LED. So your LED will glow brightly. It is for the practical. So it is for the ideal case. In the practical case, we are applying 2.5 volt. Consider this is a practical diode. So anode is connected to positive, cathode is connected to negative. So your diode is in forward bias. So this time there will be a small on-state voltage drop, that is 0.7 volt will be drop across this diode. We are applying 2.5 volt, 0.7 volt will be a drop. The remaining voltage, that is 2.5 minus 0.7, remaining 1.8 volt will be applied across your LED. So your LED will not go brightly but it will dim. So this is the difference between ideal diode and practical diode. So let us discuss about the reverse bias. What is reverse bias? We know very well about forward bias. Whenever the anode potential greater than the cathode potential, it is known as forward bias. If anode potential is less than the cathode potential, then it is called reverse bias. Your anode is more negative than cathode. So VA less than VK. So this condition, during reverse bias, your diode acts as a off switch. During forward bias, your diode acts as a on switch. So we will discuss about the VA characteristics of PN junction diode during reverse bias in the next lecture. Thank you.